Hi everyone, I'm going to go through the hardware in the loop simulation stuff with Aerodynamic Objects. So what we have here is a simulation of a very large quadcopter in Aerodynamic Objects. That's running on Unity. I have a Pixhawk which is set up to control the plus configuration quadcopter. I've not plugged in my receiver right now, so just the autopilot. Nothing's plugged in, so I'm just going to take you through the entire process of how you get it working, because in the past there was a few steps extra which are no longer there. So first things first, I'm going to plug in the serial port for my autopilot, and I have some handy USB ports in the back of my monitor. So that's that connected. Next step is to select the quadcopter that I want to use, go into the flight controller, and I'm going to set up flight mode to be hardware in the loop with simulation user inputs. So that means that as the simulation user, I can provide inputs so that either keyboard and mouse, maybe a game controller or something like that. The alternatives are the radio control inputs, so that's if I had the RC turned on and connected to the autopilot, it would receive its inputs from that. And then finally there's these guidance inputs where we could have some kind of guidance system in the simulation doing kind of swarm control and things like that, and then the inputs would come from there, kind of like an fully automated thing. So yeah, simulation user inputs, make sure that my serial server is set up, and I'm going to tick the box that says forward on UDP. So that means that any communication between the simulation and the autopilot will also be passed out on a serial port to the ground control, and the ground control is told what port the simulation is on, so that then something like Q ground control can talk back to the simulation as well as see what's going on. So as far as Q ground control is concerned, the autopilot is talking straight to it, as you'll see in a moment. So we press play, it runs through connect, and currently it's in stabilized flight mode, so it's just going to stay there. So this is all controlled by the Pixhawk. I can then start providing inputs, so pitch forward, increase the throttle, decrease the throttle. This is an incredibly, this is a 6 meter wide quadcopter, that's why it's extremely slow, it's a lot of inertia. So this is running, it's forwarded on UDP, so we can open Q ground control while the simulation is still running, and we see hardware in the loop warning, and we have our quadcopter here connected, and it's saying that it's failed some pre-arm checks. It's actually apparently in flight mode, in manual flight mode. See if we can swap it. Maybe there's some kind of position hold on the autopilot there. Yeah, generally when I press hold, the autopilot just kind of falls out of the sky and I lose all control of it and crashes. But then we can go back to stabilized mode and start flying it around. Currently not providing a decent GPS location, so Q ground control doesn't know where we are. I don't think. Maybe it does. I can't remember what GPS is providing. Okay, it thinks we're somewhere in Africa. That might be because... Yeah, okay, my Latin long references are pretty bad. Actually. But anyway, incorrect GPS coordinates aside, we have everything working here. So Q ground control, we should be able to go in and say, let's tune in one of the PIDs or something, or I mean, I'm not used to this kind of interface, but there's your velocity and position, attitude controls, things like that. We could change parameters in here, and it should all get sent over to the autopilot, because this is communicated with the simulation. Anything that the simulation receives on the UDP port just gets passed straight through. to the hardware itself. So it's all set up and working.